Hi, my name is Steve Dudkiewicz and I'm Vice President of Marketing and Business Development at Mori Microwave. We're here this week at European Microwave 2021 in London, England, and we're showcasing our latest state-of-the-art device characterization solutions. Behind me, you'll see the world's only sub-THz active load pull system. What is active load pull, you ask? Active load pull is the art of actively changing the load impedance presented to a device under test and measuring its performance parameters. That's especially important as we want to optimize circuits for amplifiers and characterize subsystems. What is unique about this solution is that the active load pull system has been designed and optimized specifically for waveguide extender heads in the millimeter wave and sub-THz frequency range. As we move into 6G and beyond, frequencies at 140 gigahertz, 170 gigahertz, even 500 gigahertz and 1 terahertz become important. So let me spend a minute explaining what the system looks like. We start off with Keysight's state-of-the-art PNAX vector network analyzer with Virginia diodes millimeter wave extender heads. This basic system together is capable of measuring S parameters up to and including 1.1 terahertz based on the heads provided by Virginia diodes. In this example, we have D-band heads covering up to 170 gigahertz. As Virginia diode says, D-band is the new E-band. In addition to the basic S parameter measurement setup, we have Vertigo Technologies, another partner of Mori Microwave and Keysight, vector modulator unit, which allows us to adjust the magnitude and phase of the signal being injected into the millimeter wave extender head, which then allows us to manipulate the signal coming out of the extender head. By controlling the magnitude and phase of the signal coming out of the extender head, we are able to present user-defined impedances to the device under test. Before the system, active load pull was only possible in coaxial environments up to 67 gigahertz. Now with this system, we're able to achieve active load pull measurements up to and including 1.1 terahertz. What you see on the screen behind me is a typical measurement at 140 gigahertz. In the upper left-hand corner, you see gain compression power sweep traces. In the upper right-hand corner, you see power added efficiency as a function of power. In the bottom left-hand corner, you see the impedance grid that we've presented to the device under test. And finally, in the lower corner, you see the actual load pull ISO contours, and it shows how the gain is changing as a function of impedance. With this state-of-the-art system brought to you by Keysight, Virginia diodes, Vertigo, and finally Mori Microwave, we're able to extend active load pull measurements from the previous limited 67 gigahertz all the way up to 1.1 terahertz, which allows us to characterize our device technologies for 6G and beyond. Thank you.